Do you feel the vibes?
Right. So, okay. So before we do anything, okay, in order for us to be able to do, the trig functions, right? So, for example, things like this last page, right? In order for us to be able to do that efficiently, first of all, you have to be really well versed when it comes to the right triangles. Okay. So we have, the 45, 45, 90, and we have the 30, 60, 90. So take a look at this one. So suppose this is, 30 degrees and 60 degrees, right? You have to really quickly be able to label the sides to this. And the side lengths are going to be a 1, a root 3, and a 2. So in this case, you go in here and this is a 1, this is a root 3, and a 2. You have to do that very, very quickly. Okay? Or if your triangle looks like this, right? This is the 60 degree and the 30 degree. So now, where does the 1 go? On the vertical or the horizontal side? Horizontal. And then what goes on the vertical side? Root 3. And so this will be a 2. Okay? And so, okay, so it can be in that orientation. Now, when I draw my right triangles, it's always oriented in this way, okay? Like, I always draw mine like this because, I'm so used to it being, like, on the X and Y axis like this, okay? So now, suppose you do have, like the X and Y axis like this. What if, your triangle looks like this, okay? And you have 30 degrees here. So is the vertical side here the 1 or the root 3? The 1. What about the horizontal? Root 3. And this will be a 2, okay? So in the same way, if you have it, here, and let's say this is 60 degrees, what would that vertical side be? 1. And what would the horizontal be? Root 3, and that'll be a 2. Okay, so that you have to be very, very quick with. The next one is the 45, 45, 90, in which case the two legs are 1, and then you've got a root 2. So this you have to be like very, very quick with setting it up. Okay, the next element to this is graphing or drawing your angles. So when you have a page like this, like you did on the homework, okay, let's talk about how to graph or how to draw each of these angles. Okay, yeah.
Are we required to draw it?
No, but you have to know what quadrant it falls in. Okay, so take a look. So here, right, you have this. Okay, the initial side is always here. And now, each corner here is half a pi. So this is half a pi, and then when I go to this, opposite x-axis, that's a full pi. So when you have to graph something like this, 2 pi over 3, you could always write that as 2/3 of a pi. The numbers first, then the pi. 2/3 of a pi. So now you have to ask yourself, if you have 2/3 of anything, is that less than or more than half a pi? Is 2/3 less than or more than a half? More than a half. Okay, is 2/3 less than or more than a full pi? Less, right? So it's going to be somewhere over here. Okay? All right. Before I do anything on this page, I'm just going to go through and draw all of these. So here, oops. Okay, so here I have, my initial side. What? Where do they all go? Where are they going? Okay, so here, oh my gosh, what is it doing that for? That's the scariest thing. Okay. Let's see, is it going to stay this time? No, my God. Okay. I know, it really does look like it's haunted. All right, let's see if we're going to have better luck now. Let me just take a look. Okay, so here we go. Okay, so here we go. So this is my initial side. So 3 pi over 4, this is the same as 3/4 of a pi. So is 3/4 less than or greater than a half? Greater than a half. Is it less than or greater than 1? Less. So it's going to be over there. Okay, 3/4 of a pi. Okay, this next one here. Okay, this is the initial side. And my angle is 0 degrees. So it's just there. Okay. All right, next one. I have 3 pi. All right, so here we go. This is 0. Okay, up to here, it's how many pi? 1 pi. What about now?
2 pi.
And now? 3 pi. So this will be on the opposite x-axis. Okay, next. 7 pi over 6. So again, I write this as 7 over 6 pi. Oh my gosh, it really is haunted. Okay, so let's write this as 7 over 6 pi. Now, when I have it as 7 over 6 pi, this is an improper fraction. Let's write it as a mixed number. This is the same as 1 and 1/6 of a pi. So, when I graph 1 pi, I go here. Then, when I graph 1/6 of a pi, is that more or less than a half? Less, a lot less, right? 1/6 is just over there. Okay? So here we go. It would actually look more like that. Okay? All right. Next one. I have cosecant. Okay, so I have 300 degrees. So I start here. 300 degrees is in this quadrant right there. Okay? Okay. Next, I have 10 pi over 4. So that's 10 over 4 pi. But I can simplify that, right? To 5 over 2 pi, which is 2.5 pi. Is that right? So I start here. I go 2 pi, and then another half pi, and I end on the y-axis right here. Okay? Okay. So now, actually, let's pause here for a minute. So if this is 0, we know that this is pi over 2. What's the one here at the bottom?
3 pi over 2.
3 pi over 2. And actually, there is a pattern here, right? Because when I'm up here, right, it's pi over 2. Then down here, 3 pi over 2. Then back up, 5 pi over 2. 7 pi over 2. 9 pi over 2. What would it be then? 11 pi over 2. And then 13 pi over 2, 15 pi over 2, 17 pi over 2. So you can just keep going and going and going. Okay, lastly, 240 degrees. It starts here. Okay, 180, right? And then how much more do I have left? 60, so I have to go into this quadrant here. Okay, are we okay with drawing all of these angles? You have to be able to figure out which quadrant each of them lands in. Yes?
So I thought that to do these, I was supposed to find the reference angle. Is that not how to do it?
You do, but you also have to figure out which quadrant they're in. So first I wanted to do a little bit on like how to draw the angle to see what quadrant it's in. You need both. You need both. Okay? Okay. So you also need to know what quadrant they're in because that's how you're going to figure out if it's positive or negative. Okay? What I want to do next is I want to see which one of these are quadrantal angles because quadrantal angles are evaluated a little bit differently. So which one is a quadrantal angle here? What number? 15. What else? 16. What else? 19. Okay, because it either lands on the x or the y axis. Okay, so For the quadrantal angles, you have to figure out what the coordinate is of the terminal side and evaluate from there. So here we go. This point over here, we need to come up with a coordinate. Now, I know that the y value is 0. Okay, yesterday in the notes, we said, okay, this would have, a value of r, and then that would be r, right, for the x value. However, that's a good way to do it formally, but all the people, nobody uses r. Like all the cool people use radius as 1. So if we set the radius every single time as 1, then here, this would be 1 comma theta, right? And this is x over y. So one thing we also need to know is sine of theta is y over r. Cosine of theta is what? X over r. And tangent of theta is y over x. Above all else, this you need to memorize. I know I'm always telling you not to memorize this, this you have to memorize. Okay, so know that sine is associated with the y, cosine with the x, and so on. Okay, so here we go. For the cotangent here, it's going to be x over y, which is 1 over 0, which is undefined. No, it's x over y. Cotangent is x over y, so it's undefined. Okay? If you write 1 over 0 as your final answer, it'll never be full credit. You have to say undefined. Okay, here, let's come up with a coordinate point. What would the coordinate point be over there? If the radius is 1, how much would it be? -1 and 0. -1 comma 0. Okay, so secant is the reciprocal of cosine, so it's r over x, which is 1 for the radius, over -1, which is -1. Cool? Okay. Lastly, the coordinate here is 0, comma 1. Sine is y over r, which is 1 over 1, so that's just 1. Okay, now, all right, so those were the quadrantal angles. Now let's do the ones that are not quadrantal angles. So the first thing is sketch it so you know where they are. The next step is you need to know what the reference angle is. So for the first one here, theta prime is pi over 3, okay? Meaning I need to find secant of pi over 3. Okay, this is the reference angle, pi over 3. So when I make a right triangle here, pi over 3 is like how many degrees? 60. Okay, so will this vertical side here be 1 root 3 or 2? Root 3. Because 60 faces that, so it's root 3. This would be 1 and this would be 2. Secant is like cosine, so it's hypotenuse over opposite. So how much? Hypotenuse over adjacent. So how much would it be? 2. 2 over 1. Now the next step, the last step is cosine or secant positive or negative in this quadrant? Negative. So negative. Okay? Because remember, all students take calculus. This is the one with the S. So sine is positive. That means cosine and tangent are negative. Okay? All right. Next, tangent of 3 pi over 4. Okay, so what is the reference angle here? Pi over 4. Okay, so that's 45 degrees. So that means the lengths of the legs here are 1 and 1. And if I want tangent, that's y over x, which is 1. Okay, 1 over 1, or opposite over adjacent. In this quadrant, is tangent positive or negative? Negative. So -1, right? Only sine is positive. Okay. So let's move on to this one. Okay, reference angle here is 7 pi over 6. So right here, the reference angle is 7 pi over 6. I'm sorry, pi over 6. So this would be 30 degrees, right? So when I draw my triangle here, how much is the, okay, who says the vertical side is 1? Here. Who says the vertical side is root 3? It's 1, right? Pi over 6. Pi over 6 is the smaller angle, so it's 1. Okay, and this is root 3. So it would be, okay, cosine. Adjacent over hypotenuse, so how much would it be? Root 3 over 2. Okay, is cosine positive or negative in quadrant 3? Negative. Okay, so here we go. Okay, raise your hand if you think the reference angle is 30 degrees, 45 degrees, 60 degrees, 60 degrees. Okay, so now we make a, right triangle. Okay, so now, vertical side, raise your hand if you think it's 1. Root 3, it's root 3. So this would be 1 and that would be 2. Okay, so I want cosecant of 60 degrees, which is hypotenuse over adjacent or opposite? Opposite. So what would this be? 2 over root 3, which is 2 root 3 over 3. Is it going to be positive or negative? Negative. Good. Okay. Next, tangent of 240. What's the reference angle? 60. So I want tangent of 60. Okay? This is 60 degrees. Root 3, 1, and 2. From 180 to 240, it's 60 degrees. So always go from the x-axis up or down. So the tangent here would be opposite over adjacent, root 3, positive or negative? Positive. Okay, so now, fine, perfect. We did this. Oh my gosh, wasn't it lovely? Seamless. Okay, yes, because, I was guiding you through it, and I've been doing this since, wow, a long time ago. Since the last millennium. Okay, now you have to do it on your quiz tomorrow. So just to give you an idea of the quiz, this is the practice quiz, right? So you've got 1 page, 2 page, 3rd page is this. All this. Okay. So this entire page, there are 1, 2, 3, 4, 5, 6, 7 of them. 7 of these should not take you more than 10 minutes to do. Okay? So, how do you get quick at it? I just did this. You have to do it again. There are blank ones of this on MyJag. You have to print yourself a blank one, or don't even print it. Just open it up on your screen and do these again, right? You haven't memorized this. Like a couple hours from now, if I ask you, hey, what did we get for the cosine of 7 pi over 6? You're not going to remember what you got. So do these again. There are more in your notes. Do them there. There is more in the practice quiz. Do those. Open up the book. There are more over there. Or do what I do when I'm coming up with problems for your tests or quizzes, right? So just write down, okay, sine, cosine, tangent, secant, cosecant, cotangent, and then, do another set. So now you have 12 of them. And then just go and put in random angles, right? Like 7 pi over 3, 3 pi over 2, 5 pi over 4, okay? 2 pi over, I don't know, whatever, 3, whatever, okay? And then do them. You can come up with an infinite number of them, right? You just did statistics. If you have 6 functions and however many angles, how many possibilities can you come up with? And then you can do that again, okay? Yeah.
If you can get which quadrant it is in your head, do you have to sketch it out or
No. Okay, boy. Okay, No, you don't. Eventually, the point is okay. So the end game eventually is if you're walking down the street and somebody stops you and says, "Hey, what's sine of pi over 3?" It should be like root 3 over 2, just like that. Okay? So that's where we're headed. The sooner you get there, the better it is. Fine. So, eventually we should all be doing it without really having to draw anything. So, but for now, go ahead and do what I did so you don't confuse yourself and you're not just staring at the page, right? So here's what I tell my own children. Whenever you have a math problem, don't just stare into like empty space to figure out how to do it. Write stuff down because that gets like your brain going. Okay. All right. So let's work on the practice quiz.
Press start.